Okay, now we're going to start talking about names and formulas for ionic compounds. In this video, we're going to talk about writing the formulas for them, and in a later video, we'll talk about naming. Now, just like SI units, scientists have a universal system for naming compounds and writing formulas for those compounds. So you should be able to write the formula if you're given the name, and then you also should be able to write the name if you're given the formula. You need to be able to go back and forth between the two. Now, the chemical formula for an ionic compound is called a formula unit. And a formula unit represents the simplest ratio of the ions involved. And I'll show you what that means in just a moment. Now, oxidation numbers. These are the charges of monatomic ions. So charge equals the oxidation number. They just have two names. Now, monatomic ions are just ions that have one atom only. So when we talked about earlier in an earlier video, when fluorine gains one electron, it becomes a fluoride ion. That would be a monatomic ion because there's just one atom. Let's label our periodic table with their charges. And just so you know, these are common monatomic ions, but you don't need to write that down because we're fixing to label our periodic table to show us where the charges are. All right, this is the periodic table, so I want you to get yours out. Pause the video and go ahead and label your periodic table as the charges are listed here. And as you can see, the first column is 1 plus, 2 plus. We skip the transition metals again because they change charges. They don't have the same charge each time. Boron's group is +3. Carbon is plus or minus 4. Nitrogen's group -3, then -2, -1. The hydrogen being over here, ignore that. We'll talk about that in class, but you can just ignore that. So the fluorine's group is -1, and then noble gases are 0. They don't have a charge because they don't need any more electrons or need to lose any. They're just completely happy because they have 8 valence. Now, the cation, which is going to be the metal, always comes before the anion. And just to describe, or so that you understand the different parts of a formula, subscripts are the lower numbers that show us how many atoms we have. When we use superscripts, they're the higher numbers that show an atom's charge. And I believe we've talked about this before, but a way to remember that is superscripts are like Superman, they fly high in the air. Subscripts are like submarines, they float low below the surface. Now, there are two ways to write chemical formulas for ionic compounds. One is the crisscross method, which we're going to look at. The other is the balance of charges method, which you've kind of already seen with us drawing chemical bonds, but we're going to look at that as well. So let's go ahead and practice these methods. Okay, now here are the steps to writing with the crisscross method. The first step would be figure out which elements you're writing the formula for. So if I said something like write the formula for calcium and fluorine, and I might say write that either in words or I might just use the element symbol. The next thing you do is you find the charge. So look at your periodic table. If you look at your periodic table, you're going to see that calcium has a 2 plus charge and that fluorine has a 1 minus charge. Now we crisscross. We just take this 2. It's going to become the bottom subscript for fluorine. And we take this 1 and we place it at the bottom of calcium. So to write our formula, we say Ca1F2. Now, the only thing is, we really don't want to see this 1 because the 1 is understood when we see the element symbol. So how we would write this is CaF2. Now, this is the most simplified it can go, and that's what the formula unit was talking about. If we have an example, let's look at an example like this. If I have calcium and oxygen, if you'll notice, calcium has a 2 plus charge, oxygen has a 2 minus charge. If we do the crisscross method, then we get Ca2O2. That is not simplified. We can actually divide both of these numbers by 2. So to write the correct formula, you would simply write CaO. So just making sure you always write it in the most simplified form. Now let's look at these same examples, but using the balanced charges method. Now, calcium and fluorine. Calcium has a 2 plus charge. Fluorine has a 1 minus charge. That means I need another fluorine to balance out this 2 plus charge so that they all cancel now. So then you can write your formula from there, CaF2, knowing that you need 2 fluorine. Okay? So let's look at calcium oxide. Calcium, oxygen, so we have a 2 plus charge, a 2 minus charge. They both cancel each other out, so we know that we need 1 of each, CaO. So those are the 2 different methods, and you can choose whichever method you like the best is fine. You can also draw them out like we did in the first couple of videos. That also shows you how to write a formula as well. Now let's get back to notes. Let's talk about writing ionic compound formulas if the metal is a transition metal. Now if your metal is from groups 1, 2, or 13, you don't have to worry about this. But if you have a transition metal in your ionic compound, then you've got to figure out what the charge is, and you either look at the name of the compound that they give you, or you look at a list that I'll provide for you to determine the transition metal's charge. Now, for an example, the name iron, in parentheses, Roman numeral 3, oxide equals, and what they do, iron 3 tells you that the iron has a 3 plus charge. So we know that we can put iron 3 plus, oxygen 2 minus, we crisscross to get Fe2O3. Now what I'd like you to do is go ahead and pause the video and write out what you would get for zinc 2 fluoride. How would you write that formula? And then resume the video once you're ready to see the answer. Alright, to write the formula for zinc 2 fluoride, we have to know the charge of zinc, and the Roman numeral tells us that it's 2. And remember, metals are always positive ions, so that's how we know it's 2 plus. And then we have a fluoride ion that's going to be a 1 minus. From the periodic table, you should have seen that. So now we can crisscross to write our formula, ZnF2. Now let's talk about writing ionic compound formulas when you have polyatomic ions. Polyatomic ions are an ion with 2 or more elements. So a monatomic ion was an ion with 1 element. Polyatomic is 2 or more elements put together. Therefore, a polyatomic compound is an ionic compound with 3 or more elements put together. Let's practice identifying polyatomic ions and writing the formulas for those type of ionic compounds. Okay, this is a list of polyatomic compounds, and I want us to practice identifying where the polyatomic ion is in these compounds. Now, as you can see, there are 3 capital letters. That means there are 3 elements or more. That's the trick, because every time there's a capital letter, that means a new element has started. So the first thing you can do is, if you get your chart out that I've given you in class, obviously if you just recognize one, then that's fine. But if you need to determine which one it is and you're confused, what you can do is take the first 2 elements and look on your list to see if this is one of your polyatomic ions. You're going to realize that it is not. So that means then you need to move to elements 2 and 3. So let's put that back up. So then we can move to these elements, because it's just process of elimination, and realize that that is on the polyatomic ion chart. So the polyatomic ion in this first compound is going to be sulfate. So I would like you to pause the video and resume once you're ready to see the answers and locate the polyatomic ions in these compounds. Alright, the polyatomic ion for this compound is chromate. For this third compound, it's nitrate. And this next one is nitrite. And in this bottom one, it's ammonium. Now, in writing the formulas for these, you do the same thing we've done for the other ones. So if I ask you to write a formula for magnesium and sulfate, you look for the charges. So the polyatomic ion, you look on their chart to see that it has a 2 negative charge. And in magnesium, you look on your periodic table to see that it has a 2 plus charge. So I've placed the 2 down there and this 2 down here to give me Mg2SO4, and it's saying that I have 2 of them, so I'm going to put it in parentheses, but actually these 2's cancel out, so I can just write MgSO4. Now, the polyatomic ions can never be split apart. So if you have more than one of the polyatomic ion, you have to put parentheses around it to represent that there's two of the entire polyatomic ion. Now let's look at if you had lithium and let's see, let's just do sulfate again. If you had lithium and sulfate, we'd have 2 minus, and lithium's 1 plus. So when you go to write the formula, you're going to crisscross, and you would simply write Li2SO4. And since there's only one SO4, you don't need parentheses. Okay guys, that ends this video. So what I want you to do to summarize is I would like you to tell me if you're sunny about writing formulas, if you're cloudy about it, if you're stormy about it. If you feel sunny about it, you feel really good about it, then tell me 2 main important things that you learned today. If you're cloudy or stormy about this topic, please give me 1 or 2 questions written down that we can answer in class. I hope you have a great evening, and I'll see you in class.